All right, good morning. Happy Monday. Hope you guys had a good weekend. Just a couple lessons left of new material. We'll have using trigonometry for front sides and angles, and then we'll be just using trigonometry to solve problems. And so last time we looked at the trig ratios. So here, a couple things we want to make sure we have. I have a right triangle, and I have angle A. Already went through, used Pythagorean theorem, saw that this is going to be square root of 56. And I went ahead and created the trig ratios just for a reminder for us. So we have sine of A, remember we always want that angle, is the opposite over the hypotenuse. Opposite side over the hypotenuse. So if this is A, I can go, still got my daughter's pen on there. I'll show you her beautiful work later. We look over here, this is the opposite side, so I have square root of 56. This is always the hypotenuse. This is the adjacent side, and so I have the adjacent over the hypotenuse, so I got 5 over 9. And tangent is opposite over A, which is 56 over 5. So a couple things we want to always remember, we're always doing the sine of an angle. And the sine is the opposite over the hypotenuse, the cosine is the adjacent over the hypotenuse, and the tangent is the opposite over adjacent. It doesn't matter what angle A is, as long as it's always angle A, this is always going to be the same. We're dealing with similar triangles. This is now our similar ratio, and that's what we're going to look at today. So, how do we use trig ratios for a specific angle? So maybe instead of the sine of A, I want to know, saying, okay, well, what's the sine of 74 degrees? So what's this asking? This is asking if I have a right triangle, and I have a 74 degree angle here. Here's my opposite side, here's my hypotenuse. So let's call this X, maybe let's call this Y. I want to know basically what, if this is 74 degrees, I want to know what X divided by Y is. And so we can do that using GeoGebra. So if I go over and I do my, and I go from my GeoGebra and I can start creating a triangle. This says nothing about the length of that leg, but then I can come down here and I can do my angle with a given size. And I'm going to do A to B. And what did we say? We said 74 degrees. And I want it to open up clockwise for me. So I'm going to do it the other way clockwise. And I'm going to draw a ray between there. So there's 74 degrees. So now the only other thing that I need is I need a right angle. If I don't have a right angle, it's pointless. So I'm going to come in here and I'm going to draw a perpendicular line. Perpendicular line through point A through this. And that gives me a point up there. And it now is a right triangle with 74 degrees. And I wanted to know what my ratio was between the opposite side and the hypotenuse, my sine ratio. So let's get our lengths here. So between A and C, it's 26.9. So I'm going to go over here and I'm going to say 26.9 is the opposite side length over the hypotenuse, which is B to C. I get 27.9. So then I come back over here and I see that that is 27.9. Decimals and fractions are kind of strange. And so a lot of times whenever we're dealing with sine and all that, we're going to actually just kind of divide this ratio out, kind of look for it. And so if I go over back to my calculator over here, I'm going to do, there's me figuring out that square root of 56. We're going to do 26.9 divided by 27.9. And I get 0.96. I'll do 0.964, yes. And so I get this equal to 0.964. Couple things to think about. This is never going to be above 1 because the hypotenuse is always on the bottom and it's always the longest length for sine. And cosine for tangent, it's a little bit different because it doesn't have the hypotenuse. But that's not what we're looking at. We're now looking at the idea that the sine of 74 degrees is equal to 0.964. So the ratio between the opposite side of 74 degrees and the hypotenuse of any right triangle is going to be that. So now we got to ask ourselves, well, how do we use that? Do we have to go and create this triangle every time? We can. That's a lot of work. Thankfully, we have computers now, and we don't have to create these right triangles. Back when trigonometry was first made, I bet that we did go ahead and we created these right triangles, and we created these angles and found them in a smaller scale, and found the lengths. But now we have these things that are right here. Look, sine, cosine, tangent. And so I don't have to do much. Now I just say, okay, well, I want to know what the sine of a couple things to make sure. I suggest using decimals calculator. Up here it says degree. You can also have radians, which is more algebra 2 and practice for always going to work in degrees. But I want to know what the sine of 74 degrees is. Look at that. It's pretty close. GeoGebra is probably rounded off a little bit, but 0.96, it's perfect. That's what I want. And so now I am just going to use these to find my ratios for this. I'm going to be as exact as possible, and I'll show you guys what I mean with that. But let's go over here and let's do some work. Let's say that our goal is to find, I have a right triangle with 17 degrees, and I want to know what x and y are if this is 11 line tails long. And so I can kind of go through, and I'm going to give myself a little bit more room. I can go through and say a couple different things. First off, let's identify what our angle is. I have 17 degrees. We could come over here, we could figure that out because we know it. I'm going to focus on 17 degrees. And I'm going to go over and I'm going to say, what is x to 17? Well, x is that opposite side. All right? And then I have this 11. And what is that I have to the 17? That's my hypotenuse. What ratio deals with O and H? Well, it's sine. So I'm going to look at the sine ratio. So I'm going to say that the sine of an angle of 17 equals my opposite side. What's the value of my opposite side? Well, I'm looking for that. So that's my x divided by my hypotenuse. What's my hypotenuse? 11. And there's my equation to help me find x. This looks crazy, but it's just a number. If I go into decimals, I can type in sine of 17, and it'll give me something else. So I can type in sine of 17, and it gives me a number. But I want to solve for x, and so I'm going to focus on this ratio over here. I'm going to focus on that ratio by saying I'm going to multiply. The x is being divided, so I'm going to multiply by 11, and I'm going to multiply by 11. So 11 times whatever the sine of 17 is going to equal x. And I'm going to come over here to my decimals, and I'm going to say 11 times 17, and I get 3.2. So x is equal to 3.2 line tails. Now what about y? Y, if I look at it right here, again, in regards to my angle, what is it? In regards to my angle, this is the adjacent. It's next to that angle. And I still have that 11, and I still have that hypotenuse. And so now, adjacent and hypotenuse is going to be cosine. So I know that I have the cosine of 17 degrees equals x, or I'm sorry, y, my adjacent side over 11. That looks a lot familiar. The only thing different is this cosine. So I'm going to multiply by 11, multiply by 11. I'm going to say 11 cosine of 17 equals x. And I'm going to go type it in, and I say 11 times the cosine of 17 equals 10.5. Make sure we're rounding to 10, so 3.2, 10.5, we're rounding to the 10, so I come back over here. This is 10.5. Line tails equals x. That's how we use our trigonometry. That's what we're going to be doing. We're not creating anything. The hardest thing is remembering, okay, what trig ratio am I using? What's my angle? What are my side lengths? So let's look at that one more time. I think I have time to look at it in 15 minutes. I want to find x and y. And so x, I'm going to first identify my angle. My angle is 52. I have 7. 7, which I'm going to use in both of them, is my adjacent side. X is my opposite side. And so with that, opposite and adjacent, I know I'm going to use the tangent of 52 degrees equals my opposite side, which is x, over my adjacent side, which is 7. So I know that I'm going to have 7 times the tangent of 52 is equal to x. Go over to my Desmos, and I'm going to say, what was it? 7. 7 times the tangent of 52 equals 8.95. That 5 rounds that up. So if I think about that as an 89, it's going to round up to 9.0. So I'm going to come over here and say 9.0 equals my x. That tells me that 9.0 tells me that I looked and it is rounded. Now look at this one. So now my y is my hypotenuse to my degrees. So I have my adjacent hypotenuse. What trig ratio is that? That's cosine of 52 still, equals my 7 over my hypotenuse. So now what's different in all of this? Notice where I'm going to call this actually y. Notice it's different. My variable is on top here. My y is on the bottom. I'm going to solve it the same way. I'm going to multiply by y. I'm going to multiply by y, and I get y cosine of 52 equals 7. Then I'm going to divide by the cosine of 52. Remember, this is an entire number. So I'm going to divide by that. I'm going to say y equals 7 divided by the cosine of 52. And when I look at those two things, I can still come over here and do my Desmos. And I'm going to do 7 divided by the cosine of 52. And I get 11.4 as my value. So I get y equals 11.4. So the little trick is that if the variable's on top, you're multiplying the 7. And if the variable's on bottom, you're dividing by the cosine of 52. That's always going to be the case. Those are the two things we're going to work on. Those are the two things we're going to do. As I scroll through all the beautiful artwork of my daughter, this is what your homework's going to look like. So you're simply trying to find x, and you're going to say, okay, I have my angle here. This is the opposite side. This is the adjacent. So that is tangent of 27 equals my x over 10. Well, 10's on the bottom, so I'm simply just going to multiply over. And I'm going to come in here and say 10 times the tangent of 27 equals my x value. And then go to our Desmos. We'll say 10 times the tangent of 27 equals 5.09. That 9 will round it up to 5.1. And so I get 5.1 equals x. And that's what you guys are doing. You have a Go formative that is just this 18 times, just practicing that. If you have questions, I will be on today from 1 to 3. So go ahead, jump on. Make sure you guys ask any questions that you may have, or just say hi. Hope you guys are having a great day.